So in this lecture, I am going to explain cycloidal curve. To construct a cycloid curve, here the problem is given. So first of all, before going to construct a curve, let's read this problem carefully. A circle of 40 mm diameter rolls along a straight line without slipping. Draw a curve traced by a point on the circumference for one complete revolution of the circle. Name the curve. Draw the tangent and normal to the curve at a point on it 25 mm above the straight line. So after reading this problem, first of all, you have to understand what is given in it. So see, here this is a rolling circle whose diameter is given, that is 40 mm, and this rolling circle rolls along this straight line without slipping. Here the point P is on the circumference of this rolling circle, is showing the contact point of this straight line and this rolling circle here. Now this point P starts to move on the circumference till the one complete rotation of this rolling circle. Means this point P starts from this contact point of this rolling circle and line, then again come to the same position, means at the contact of this rolling circle and here the line. So this circle here covering its one complete rotation. Then we have to draw here the path traced out by this point P when it moves with the rolling circle on its circumference. So this path, you can see here, this path is generated by this moving point P. Also it is asked here, draw the tangent and normal to the curve at 25 mm above a straight line. So now say here, this P to P dash is a straight line and we have to draw a tangent and normal at 25 mm distance above the straight line. So we have to measure 25 mm distance from this point P dash towards upside, or from this P point towards upside on this vertical axis. So we can take anywhere, I mean one of both the sides. So first of all, you have to draw here a circle of radius 20 mm, taking a point C as a center. Then draw here the line which is tangent to this rolling circle at point P. Then through point P, draw a vertical line which is normal to this horizontal line, and then divide this circle into 12 number of equal parts. So now say here the angle of each part is of 30 degree. So we have to divide here this circle into 12 number of equal parts. Now see here, this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and last point is 12. Means we had started from point P and then ends to the point P. So this circle is divided into 12 number of equal parts. Then we have to draw here the line of length that is equal to pi d. So d here is the diameter of this rolling circle, and pi d means the length of circumference of this rolling circle. So we have to take here the distance from P to P dash on this horizontal line equal to the circumference length of this rolling circle, and that is pi d equal to 125.6 millimeter, which is calculated by taking here the diameter 40 millimeter of this rolling circle. So now say here this circle is divided into 12 number of equal parts. So similarly, we have to divide here the distance between P to P dash in same 12 number of equal parts. So for this, we can use here the inclined line through point P or through point P dash, or as per your convenience, you can divide this distance from P to P dash, which is equal to 125.6 millimeter into 12 number of equal parts. Now say here the numbering is given from left side. So that is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash up to P dash. So here 12 parts are done of this straight line. Through each part on this horizontal line, draw a vertical line. So this vertical line intersect the line through the center of this rolling circle. The line through the center of this rolling circle is parallel to the horizontal line. So when here the line draw through point 1 dash, 2 dash, 3 dash, 4 dash, etc. intersecting on the line passing through the center, then we have to name the point of intersection of line through 1 dash and the line through center as C1. For 2 dash, we have to name the intersection point of C2. For 3 dash, C3. For 4 dash, C4. So etc. Here you see up to the 11 dash. Here the intersection points are given, and then these intersection points are considered as a centers for arcs, which we are going to draw a curve by using it. So now take a distance of radius of this rolling circle in compass. But before that, you see here this circle is divided into 12 number of equal parts, and through the intersection point of this line division and the circumference of circle means is the intersection point here at this point, at point 11, at point 1. So through the common line is drawn that is parallel to the horizontal line. Similarly, through point 2 and 10, draw a line which is parallel to the horizontal line. Similarly, through point 9 and 3, draw a line parallel to the horizontal line. Similarly, through 4 and 8, 7 and 5, and last 6, draw, through the point number 6, draw the horizontal lines parallel with this horizontal lines. Now, take the radius of this rolling circle in compass, that is equal to 20 millimeter, and put the compass sharp point at center C1. So here center C1 is given. So put here the sharp point of the compass and then cut the line, horizontal line passing through the point 1, because we have to cut for center C1 the line passing through the point 1. So here you see the point which is cut by the curve on the horizontal line 1 is represented by P1. Similarly, without changing distance in the compass, put the compass on center C2 here and cut the line passing through the point 2 on the circumference. Now see the point of intersection of this arc and line horizontal through point 2 is represented by P2 here. See, this is P2. Then put the compass at center C3 and cut the line passing through the point 3 on the circumference of circle. Here now see the intersection of this curve and the line is shown here by point P3. Similarly, repeat the process for point or center C4, C5, C6 up to C11. So last one is, this is 12 dash. 12 dash means P dash. So when you will put here the compass for the last uh, point getting at C dash, so you will get here the last point at the radius of this rolling circle. This last point will be here point P dash. Then by using French curve, you join all these points P1, P2, P3, P4, P5, P6, P7, P8 up to P dash in a sequence and dark this curve only. Dark this curve only. Then name the curve as cycloid, because this is a cycloidal curve. Now it is asked in question that we have to draw the tangent and normal to the curve at 25 millimeter above this horizontal line. So you can take here the vertical distance from point P dash on this vertical line or from point P on this vertical line. So any point you can choose, this P point or P dash point. So from this P dash point we have to take here the distance of 25 millimeter, and then through that point we have to draw here the horizontal line which will be parallel to this horizontal line at which is the tangent to this rolling circle. Then here the horizontal line which is parallel to the tangent line cuts this cycloidal curve at a particular point. Then mark that point and name that point as M. Then you take a compass in which already a distance is set, that is 20 millimeter, which is the radius of this rolling circle. Now put here the sharp edge of this compass at point M and cut the horizontal line through the center of this rolling circle at Q. See here this arc is drawn from this point M, which is cutting to this horizontal line through the center of rolling circle at point Q. Then from this Q point draw a vertical line, perfectly vertical line or normal to this horizontal tangent line. So now see this vertical line drawn through this point Q intersect here or cut here the horizontal tangent line to the circle at point N. Then this N point and this M point joined by a straight line, and this straight line show the normal to the curve. So this is the normal to the curve through the point M at a distance of 25 millimeter from this horizontal tangent line. Then through the same point, draw a tangent line. So this tangent line is 90 degree with this normal line. So in this way, we have completed here this problem in which we have drawn here this cycloidal curve as well as the normal and tangent to the curve by using the data given in problem. So thank you for watching this video. Thank you very much.